Hello. So today we are going to discuss about one of the important concepts for ninth class maths in first chapter in number system. So these two topics today in this class we are going to discuss. The first topic is representation of irrational numbers on the number line. So in the previous classes we represent some rational numbers on the number line. But here in this class, how to represent the irrational numbers on the number line. So this representation of irrational numbers is a property is there. In the previous class, I explained that is completeness property. That completeness property is saying that on a number line, every point indicates a real number. It is a unique, so that is called as a completeness property. And another one property is there, that is density property also is there. There are infinite rational and irrational numbers between given two numbers or between given two points on the number line. So on the basis of this, today we are learning how to represent irrational numbers on the number line. So already you know that the definition of an irrational number. So I have explained the two definitions about the irrational numbers. The number we cannot represent as in the form of terminating or repeating decimal. I mean, we cannot represent that in the form of p by q. The second definition is if n is a non-zero, non-perfect square number, therefore root n we can call it as a irrational. No, sorry, root n we can call it as an irrational number. So if n is non-perfect square number, therefore root n is an irrational number. Here I have taken some numbers. It is root 2, root 3, root 5, root 17, root 50. These are all non-perfect square numbers. Therefore, root 2, root 3, root 5, root 7, root 50 all are irrational numbers according to our definition. So we are going to we are going to represent these irrational numbers. Now we are going to represent these irrational numbers on the number line. So before representing these irrational numbers, student must know one theorem that is called as a Pythagorean theorem. This we learned in 8th class. That is Pythagorean triplets. So in number system only we learn in 8th class standard, that is Pythagorean triplet. That we know that the general form of a Pythagorean triplet is 2n comma n square minus 1 and n square plus 1. So this we can call, these three values are called as the Pythagorean triplets. But here a student must know the concept of a Pythagoras theorem. That is nothing but this theorem is applicable for a right angle triangle. So this, for example, this ABC is a right angle triangle where B is a 90 degrees angle. Then hence it is a rat. Rat means nothing but right angle triangle. So in every right angle triangle, this we can call it as an hypotenuse. I mean the longest side which is opposite to the 90 degrees, that we can call it as an hypotenuse of a given right angle triangle. So what Pythagoras theorem is saying means, for example, if you say this is adjacent and you say this is opposite, or you can say this is we can say H1 and you say this is H2 and you say this is H3. R means hypotenuse. So H3 square is always equals to H1 square plus H2 square. Why I taken this one is arm 1, arm 2. We can say that this is first arm and this second arm. So the hypotenuse square is always equals to the squares of the sum of other two sides. That is called as the Pythagoras theorem. So this will be applicable for right angle triangles. The biggest side we can call it as a hypotenuse. This square is always equals to the squares of the sum of other two sides. So this is the Pythagoras theorem. Every student must know about this Pythagoras theorem. By using this Pythagoras theorem, we are representing irrational numbers on the number line. So today in this class, we required to learn how to represent root 2, root 3, root 5 or a real irrational number on the number line. This method in your textbook, it is called as the spiral method, it is given. So irrational spiral, it is given, but simply I will explain. For example, you take a number line. This will be geometrical construction. You want to do this construction by using your geometry box only. So, but here I am doing without geometry box for your explanation purpose how to represent the rational numbers on the number line. For example, this is 0 and this is 1 and this is 2 and this is 3. So this is -1 and this is -2, this is -3. This is general number line, and here I have taken the same distance of points on the number line, and you can call it as unit 1. These all are equal units. So first unit, second unit, third unit. This is also 1 unit, this is also 1 unit, and this is also 1 unit. These points will be having the equal distance. Each distance we are saying as a 1 unit. So this is the number line. So on this number line, I want to represent root 2 on this number line. So for that purpose, what I am doing here, you say this point O is A. You say this point O, 0 as A. On the number line, I have taken the 0 point as A, and you take a point B on 1, first unit. This point is B. Now, by using your compass or your protractor, whatever it may be, you draw a perpendicular line on this one. You draw a perpendicular line on B, which is perpendicular to our number line. First, I have taken 0 as point A, and first unit I have taken B, and the distance between A and B is 1 unit. The distance between A and B is 1 unit. Or sometimes you will take in centimeters, or sometimes you will take some inches, whatever it may be. But the distance between these all units will be equal. So this I have taken B at 1. So the distance between A and B is 1 unit. And afterwards, you construct a perpendicular line on point B. This is perpendicular to our given number line. And you take another 1 unit on this perpendicular line by using this distance, and you take your compass and you draw an arc like this. So this is also 1 unit and this is also 1 unit. Now you take this point as C. So this is also 1 unit. I think you are following me. So this is 1 unit and this is also 1 unit, and you join A and C by using your scale. Now, if you observe carefully, I got a right angle triangle by this construction. This is like this. So here it is A and here it is B. This point is C. So already I told you this is 1 unit and this is also 1 unit. And what about AC? So you know that AC square is equal to AB square plus BC square by Pythagoras theorem. I already explained you what is Pythagoras theorem. So this is hypotenuse. Therefore, its square should be equal to the sum of these two squares. Now, AC square is equal, AB is 1 unit, 1 square plus 1 square. So AC square is equal to 1 plus 1, 2. Therefore, AC is equal to root 2. So the distance between A and C I got as root 2. So the distance between A and C is root 2 means the length of AC is root 2. You take your compass and you put your needle at A and you put your pencil at C, and by using the compass you draw an arc like this. You draw an arc like this. So if you draw that arc like this, it will be like this. So this is 0 and this arc is intersecting our number line at one point. That point is P. What is its meaning? AC, but after construction, AC should be equals to OP. I mean AP. AC should be equals to AP because we constructed by using your compass, by using an arc. So therefore, AC is root 2 I got according to the Pythagoras theorem. Therefore, the distance between A and P also equals to root 2. That is equal to root 2. Then P indicates root 2 on my number line. So by this construction, just I can represent root 2 on the number line. Next, if you see root 3, if I want to construct I want to represent root 3 on the number line, what I'm doing, if you observe carefully, I already told you this is a right angle triangle, and on C now you draw another perpendicular line. On C, At point C, you draw another perpendicular line by using your protractor. So this is the perpendicular line. It is perpendicular to our AC. This line is perpendicular to AC at point C. Now again you take 1 unit on this line. This is 1 unit A, B, C, D. So this point D is 1 unit distance from your C. And afterwards you join A and D. Now here I got a right angle triangle like this. So this point is C, this point is D, and this point is A. So here it is 90 degrees. For your understanding purpose, I drawn the triangle separately. So already according to our construction, you know that AC I got root 2 and this one I got 1. Now I want to know the value of 8. So same by Pythagoras theorem you can know, you can write that AD square is equal to AC square plus DC square. Now AD square is equal to AC I got root 2, that is root 2 square plus 1 square. So AD square is equal to root 2 square is 2 plus 1, that is equal to 3. Therefore AD is equal to root 3. AD is equal to root 3. Now I got root 3. So by using your compass, by you want to draw another arc by using the length of OD. I know that OD length is root 3, therefore that will be equals to this point you say as Q. So here my construction you can say you can write OD, that OD. AD should be equals to AQ. So that is equal to root 3. Therefore this Q indicates root 3 on the number. So this is very interesting construction. Afterwards you draw a perpendicular line on D, you will get root 4 that will go through the 2, and afterwards you draw a perpendicular, then you will get root 5. So like that you can find root 3, root 4, root 5, root 6, root 7. So all will be like this. I mean, this will be in your textbook and you will get a spiral on your number line. So if you continue, root 2 you will get, root 3 you will get, root 4 means it will go through point 2 because root 4 your value is 2. And afterwards you construct another perpendicular, you will get root 5. But this is called as a spiral. I mean, square root spiral is there in your textbook. Like this, we can represent irrational numbers on the number line. So my question is, for example, in your exam, will ask you to represent root 17 on the number line. So if you use this spiral, it is very complicated. It is easy only, but it is very lengthy. I mean, it will take so much time to construct root 7. I mean, represent root 7 on the number line. But I will tell you one technique here. So in some exams, I found that how to represent root 17, how to represent root 26, how to represent root 50. So like that, some questions I've seen. So he's asking to represent root 17 on the number line. So if the number is big one, so just you want to think, is there any choice to write root 17 as the sum of two perfect square numbers? You want to think, is there any choice to write root 17 as the sum of two perfect square numbers? So it is able to, I can able to write this is 16 plus 1. Root 17 we can write it is a 16 plus 1. Because 16 is a perfect square number and 1 also itself it is a perfect square number. So now it is easy to represent root 17 on number line in a single step. So how can I represent on root 17 on the number line is just you take a number line. So we don't want to require the repetitive numbers. Therefore, I take 0 here. This is my 1 and 2. This is 3 and this is 4 and this will become 5. So I have taken up to 5 only because root 17, I mean 17 is in between two perfect square numbers, that is 16 and 25. So 17 value is between 16 and 25 because 16 is a perfect square number and 25 also a perfect square number. So 17 is in between 16 and 25. Hence, the root value will be, the 17 root value will be, the root value of 16 is 4, the root value of 25 is 5. Therefore, the root 17 will be in between 4 and 5 on my number line. So I have taken up to 5 only. So 100% the distance between these units, I mean these numbers will be equal. You want to make same unit, I mean same distance between these numbers. Then only your construction will be perfect. While doing this construction, you require to use your geometry box. You should not draw, rough diagram. If you draw the rough diagram, you won't get marks. So this is a pure construction part. So what I am doing here, I am representing root 17 on the number line. Just you take a point A at 0. And here, I already told you, 17 I wrote it as a sum of two perfect square numbers. That is 16 plus 1. So what is the square root of 16? That is 4. Next point you take at 4. This point is B. And on B, you draw a perpendicular by your protractor. After drawing a perpendicular on the number line at point B, you take 1 unit on this number line. This is 1 unit, this is also 1 unit. You say this point is C. Now you join A and C by using your scale. So if you join A and C by using your scale, then you will get a right angle triangle here. So ABC is a right angle triangle. So this AB is equal to 4 units and BC is equal to 1 unit. Now you know that AC square is equal to AB square plus BC square. Therefore, AC square is equal to 4 square plus 1 square. So this is AC square is equal to 16 plus 1. So AC square is equal to 17. AC is equal to root 17. So this is very wonderful concept to represent root 17 on the number line. I got here AC is equal to root 17. Therefore, AC is root 17. Now you use your compass and you put your compass here A and C, and the length between A and C is 17. Then you draw an arc like this. Therefore, if your arc is like this, this is my arc intersecting the number line at one point. You say that point P. Now AC should be equals to AP. Therefore, if it is 17, this AP also, AC should be equals to AP. That is equal to root 17. Therefore, this point indicating root 17 is the number. So if you construct the root 17 by using the spiral method, it will take so much time. But some numbers you can represent on the number line by using a single step. By make that number as the sum of two perfect squares, it is easy to represent on the number line. For example, if you want to represent root 26, root 26 I can write as 20 plus 1, 25 plus 1, because 25 is a perfect square and 1 also a perfect square number. Now what I want to do, first you want to estimate where root 26 will be on the number line. Root 26 will be in between 25 and 36. I mean in between these two perfect square numbers. So 25 is the 5 square and 36 is the 6 square. Therefore, root 26 value will be between 5 and 6. This is the first, you require to estimate what is the value of root 26. The estimation value of the root 26 will be in between 5 and 6. Afterwards, you practice to write the sum of two perfect square numbers. This 26 I wrote it as 25 and 1. So then it is easy to represent on the number line. For example, 26 means you want to take A at 0 and B you want to take at 5. So this is 5 unit and this is 1 unit, and you join these two, you will get root 26 on the number line. For example, here 50 is there. This 50 I can write it as 49 plus 1. So this is 7 square and this is 1 square, and it is easy to represent 50, root 50 on the number line. For example, 13, root 13 is there. How to represent this root 13 on the number line? This is also very interesting. So 13 I can write it as 9 plus 4. 13 I can write it as 9 plus 4. 9 is a perfect square number and 4 also a perfect square number. 9 is the square of 3 and 4 is the square of 2. So you take 3 units on this and you draw a perpendicular line. On this perpendicular line, you require to take here, this is very, very important. You require to take on this perpendicular line how many units? 2 units. This is 1 unit and this is 2 units. Here you want to take C. So this is my triangle. This is my triangle. So this is 2 units and this is 3 units. So just I will clear and I will explain. Here what I am doing, I am representing root 13 on the number line by using a single step. So here what I did means I have taken A at 0 and B at 3. So these are the 3 units and I will draw a perpendicular line on B. Then afterwards I have taken 2 units on this perpendicular line. This point I have taken as C. Now you join these two. What happened? You see this is 3 units and this is 2 units. Therefore AC square should be equals to 3 square plus 2 square. So AC square is equal to 9 plus 4. Then AC square is equal to 13. Then AC is equal to root 13. So this is root 13. Afterwards you use your compass and you draw it, R. Then it's P, that is root 13. So this is the one of the interesting method. If you practice how to represent irrational numbers on the number line. And another one interesting concept is there in 9th class. That is rationalization. The term rationalization, it is very interesting. What is rationalization? What is rationalization? Rationalization is one of the important concepts for all 9th class students. There are so many questions by using this word. So first we required to define what is rationalization. Rationalization is nothing but, for example, root 2 is there. Actually, it is an irrational number. So to make root 2 as a rational, number, how it is possible? It is possible by dividing or by multiplying with some value. You can rationalize root 2 by dividing or by multiplying some numbers. Some other value, you can rationalize it. For example, if I multiply root 2 with root 2, if I multiply with root 2, what happened? Root 2 into root 2, that will become root 4, that value is 2. Therefore, it becomes a rational number. So, rationalization means you want to make the irrational into rational by multiplying some values or dividing some values, is called as a rationalization. So, this is one of the important concepts. Before going to this concept, I want to tell you one word that is called as a rationalizing factor, RF. This is very interesting word. The word we can call it as a RF. RF means rationalizing factor. What is rationalizing factor? Rationalizing factor means, I already told you, for example, root 2 is there. Here I multiplied with another root 2. Then it become root 4 and it become a rational number. So root 2 is the rationalizing factor of root 2. Root 2 is the rationalizing factor of root 2. For example, here root 18 is there. So with what I want to multiply to make it as a rational number? If I want to multiply some number and you make it as a rational number. Means so many students, they will say as root 18. That's all. If you multiply with root 18, it becomes 18, therefore it is a rational number. Yes, you are right. But here, while writing the rationalizing factor, you want to take the least number to multiply with this. For example, root 18 is there. This I can write as 9 into 2. So this root 9, if we come outside, it becomes 3 root 2. Actually, these two are both are same. So if you multiply it with root 2, what happened? 3 into root 4, again 2 becomes 6. So it is rationalized. So root 2 is the rationalizing factor of root 18. Root 2 is the rationalizing factor of root 18. So rationalization means to make the irrational into rational by multiplying or by dividing some values which we are multiplying or which we are dividing, that is called as a rationalizing factor of the given irrational number. On the basis of this, I am going to explain some important concepts about the rationalizing factors. For example, here a plus root b, a minus root b, or root a plus root b, or root a minus root. You think these are all irrational numbers. These are all irrational numbers. So this is a plus root b, this is a minus root b, this is root a plus root b, and this is root a minus root b. So you think these are all irrational numbers. I mean, these are all irrational numbers. I want to make them into rational numbers. I want to make them into rational numbers. Here I required a rational factor, rationalizing factor. So these given numbers are irrational numbers. I want to make these irrational numbers into rational numbers. So how we made to into rational numbers means we need to multiply with some values. Which value you are multiplying, that value we can call it as the rational factor of the given number. So here simple technique I will tell you on the basis of an algebraic identity, that is a plus b into a minus b is equal to a square minus b square. By using this identity, we can write all rationalizing factors of the given number. If the irrational number is in the form of a plus root b, then you write a minus root b is the rationalizing factor. If you multiply these two, you will get as a square minus root b whole square, then it becomes a square minus b. Then it will be changes into rational number. So if a minus root b is an irrational number, its rationalizing factor is a plus root b. If root a plus root b is an irrational number, then root a minus root b is the rationalizing factor of this irrational number. If root a minus root b is an irrational number, then root a plus root b is the rationalizing factor. If you multiply these two values by using a minus b into a plus b is equal to a square minus b square, then these all numbers will be changes into rational numbers. Here, I am going to tell you one important example, that is 3 plus root 2 is there. So this is in the form of a plus root b. So you know that this 3 plus root 2 is an irrational number. So according to the given thing, 3 plus root 2 is an irrational number. Then what is its rational factor? The rational factor is a minus root b. So according to the a minus root b, here the rational factor of rationalizing factor of 3 plus root 2 is 3 minus root 2. So if you use this algebraic identity, a plus root 2 into a minus root 2, then become it is 3 square minus root 2 square. So 3 square you know that 9 and root 2 square is 2 and it becomes 7. 7 is a rational number. For example, here another example I am going to take, this is root 5 minus root 2. This is also a irrational number. So what is the rationalizing factor? This is in the form of this a root a minus root b. So the rationalizing factor is root a plus root b. Therefore, the rationalizing factor of root 5 minus root 2 is root 5 plus root 2. Again, you apply this algebraic identity. This becomes a square minus b square means root 5 whole square minus root 2 whole square. Root 5 whole square is 5. Root 2 whole square is 2. Then it becomes 3. Therefore, 3 is a rational number. So here 3 minus root 2 is the rationalizing factor of 3 plus root 2, or we can say that 3 plus root 2 is the rationalizing factor of 3 minus root 2. So here root 5 minus root 2 is an irrational number and root 5 plus root 2 is the rationalizing factor of the given irrational number. So by using this rationalizing factors, there are so many questions in your textbook and different concepts. So those questions we are going to solve in the next class. But in this class, we learn some important concept. The first concept is how to represent the irrational numbers on the number line. And the second concept is rationalizing factor of the given irrational number. So by using this rationalizing of an irrational number, we are going to solve so many questions and some important conceptual questions in the next class. So you concentrate all these classes and you learn about the rational and irrational numbers and their properties and some important decimal representations of these given numbers. Thank you.